There we are. Okay. So, you understand the basic concept. Stored procedures, I mean, it's pretty simple stuff. But there are some commonly used stored procedures that you end up doing. This kind of works in harmony with the point we made earlier about how quite often the only thing we might expose from the database to a client application are a set of stored procedures. What are the most common actions any client application does? You pull out, somebody was mentioning in the break earlier, they made a little to-do application, right? The most common things you do in any client application is you insert a record, then you might update it, and you might delete it, right? The other thing, of course, you might list all the to-do items you have, okay? And you might filter them, possibly, right? So in terms of standard operations, you might say, basically there's listing everything, right? Your select stored procedures, and they might have a variety of ones that have different filters. You might want to select all your to-do items to do with grocery stores and to-do items to do with fix it around the house things to do, right? Or whatever categories you might have for to-do items. And then, of course, then there's all the actions of insert, updating, and deleting, right? So you end up having these common stored procedures, right? Some that return data. Now that could be from a table or a view, and to be honest with you, because in the real world, most database systems have all these referential integrity relationships to normalize data as much as is reasonable, we tend to break things out into multiple tables, right? Parent-child relationships and so on, okay? So even if we stick with the to-do example from our discussion at coffee break there, if we're going to have categories of to-dos, right, then you might have a categories, and every to-do has a foreign key value, right, to reference the actual category of the to-do item, right? So that's something else that we might do in terms of a data returning stored procedure. If you're going to have a drop-down list in your app, just picture that. It's on your phone in front of your screen, right, right there in front of your eyes. You're going to choose, as you're defining your next to-do item, in a drop-down list, all the categories, okay? Well, we often will make a standard stored procedure to provide the data for those drop-down lists, right? And so you think about, what do you need in a drop-down list? Well, usually there's only two columns of data needed. One is the internal value of each unique item in the list, because that's probably the actual foreign key. Maybe it's an integer identity, something like that, right? And then the text to be displayed in the drop-down list. Well, that's another data returning stored procedure we might make then to provide the data for those drop-down lists, right? That's what I'm referring to here in my PowerPoint slide as lookup data, right? And it just returns that usually a primary key, and it might be a summary field, like if it's going to be a list of names you're choosing, right? Then you put it together in maybe formal name format, last name, comma, first name, initial, that type of thing, right? So it'll just be put together as a summary field, and it's always sorted. It's always easier to find information in a drop-down list if it's sorted alphabetically. So those are some examples of common stored procedures we're going to learn to write, right? Then there's the action queries, insert, update, and delete. Now I'm emphasizing here, notice it says insert a new record, update a specific record, delete a record. Now we all know from the work we've done, you can insert bulk inserts, you can update multiple records at the same time with a update command, and same with delete. You can delete a whole bunch, with a where clause, all students in a given course, things like that, right? Their enrollments or whatever. But if you think about, again, how you normally work, typically in that to-do app on the phone right in front of your face, you'll typically add one item at a time. You might update or make changes, an edit of one item, and delete one item at a time. So they are also standard stored procedures that we typically write. So at the minimum, you're looking at 5 there. Select everything from a given collection of data, whether it's a table or a view. Select usually one at a time, indicated by the primary key, and then 3 for the different actions, an insert, update, and delete, standard stored procedure. 5 at the minimum for every entity that you work with, right? So that's what we're going to kind of review now. Now there's additional ones. Usually for other filters, we'll have additional select stored procedures, whether you want to filter by foreign keys or collections of other things as well. Okay. So select with no restriction, no where clause, right? And now often what we'll do is in the data returned in our select queries, Okay? We don't need to display, for example, think of if there's an integer identity primary key for our categories, for our to-do items. The fact that this particular to-do item is in category 27, that's not very useful to the end user, right? We're going to show the name of the category, okay? That it's, what did I say earlier? Household chores or whatever, right? Or fix-ups around the house, right? That's what we want to show. Now that's stored in a separate table, so more often than not, our select procedures are based on a view, right? And that view will have our inner joins so that we can actually include all the relevant information to show on the screen, okay? So it probably should include the actual foreign key value from the main table, but from the lookup table or the related table, we'll just pull the actual descriptive name of whatever it is, right? So that's an example of eager loading, that instead of having to go back, make a second trip to go back and get, say, the name of the category, we'll eagerly load that data into the one select, so all the data we're going to need to present in the user interface comes at once, right? Okay. Select by the primary key value, because when we want to focus in on one to-do, well, we need to know its primary key, so we'll pass that unique identifier and get the entire record brought down that we need to focus on one at a time, right? And as I said, additional select procedures will be created. You know, maybe we'll often want to filter, right, and sort by different values. So, you know, we'll have different procedures set up for that. For the DML procedures, the insert, update, and delete ones, okay, one of the things that we'll do in our stored procedure for an insert, we want to make that if there's a newly generated primary key, the client is probably going to need to know what that is. They don't always, but in many cases they need to have that information as soon as possible. So usually that is set up as something to be returned. So it could be an output parameter or in some other way sent back to when the procedure is called to execute right away. So there are ways that we can actually have the system tell us what the newly generated primary key value is right as part of the code. And we'll show you a couple of those approaches in a moment, right? Now an update, okay, here is where we very often will have some sort of version control, right? You've talked about row version or timestamp properties in the past, or fields? Yeah. So in the real world, it's very, very common to have that timestamp or row version to any table so that you guarantee that two people aren't updating the same record at the same time. One person's update overwrites the other person's, but they aren't aware, right, that happened, right? So you can easily manage that concurrency issue by having a timestamp parameter. So when we write our update stored procedure, assuming there will be a timestamp or a row version there, then we'll use that in the where clause to make sure that it hasn't changed since the user got their copy of the record that they think they're updating, right? So that's something we'll include in the code for our update stored procedures. In the delete, okay, you may or may not worry about, okay, it's a design decision. You might implement version control or concurrency control for the delete is the same as update. Quite often we don't bother, but you can do that if it's something that's critical. That, you know, if the idea here is that you look at a record and all the information you have on your screen and you decide to delete the record. But if somebody in the meantime, between you got your copy that you're looking at, if somebody has made an edit and changed something, then you might not have the full picture to help you decide properly if you should delete it or not. So if that could be the case, then we'll make sure we add version control or concurrency control to our delete as well. Okay. Now we talked earlier about, I mentioned this no count option, right? And here's our general rule of thumb. For data returning procedures, the ones where we use a select, we should set no count to on, okay? It'll save message traffic by eliminating unnecessary information because you're returning the data. They have everything they need. They don't need to be told in a separate message how many records you just returned. They have the records themselves. But for our action queries, the insert, update, and delete, we make sure we set no count to off. We put that right in the code, even if it's the default, right? We want to make sure that those messages are returned to the client because the client will sometimes count on that information coming back to know, for example, if you did a delete, right? If it didn't raise an error, but it failed for some reason, okay, then they can check. If it says 0 records affected, basically, then they know the delete failed, even if it doesn't raise an error. Same with an update, okay? Maybe there's no error, but it couldn't update it for some reason. Well, you will know that because you set no count to off, and the message will come back that 0 records were affected, right? Okay. Yeah, there are other ways we could do it, but this is built in, and so this is a standard approach that we use in our standard stored procedures, right? Okay, so I have some guidelines here just to help you. Basically, these are broken down into the 2 main data returning and action ones, right? So we're going to start with some assumptions. We don't always have integer identity primary keys, but in many of our situations we do, right? So we're going to start based on that common assumption that that's one of the things we have in place. Every table has an integer identity. I'm going to just call it ID. Timestamp fields have been added for concurrency control, and we've also added a couple fields for audit information, okay? Updated by and updated on, okay? So it'll have the updated by, will have the username of whoever did it. Now, mind you, you don't always have that available, so we make sure we have a default, such as like unknown or something like that, right? So something is stored there. And updated on will have the date time, right, for auditing purposes, okay? Now, you might also, very commonly, will have 2 additional fields, created by and created on, right? Now, once the record's created, they never change, but it gives you that history of who initially did it, and then you also know who last updated the record, right? And that's what we often refer to as simply basic auditing, those 4 fields together. Sometimes you decide I don't need the created information, I just need to know who last changed it. Okay? All right. Okay. We're going to write procedures to match the data you have in your tables, of course. Okay? So basically, here's our formula, you might say. These are templates, right? So for our select all procedures, okay, you might be from a table or it might be from a view. Very commonly, we use views if there's any related information that we want to show on the screen. So the procedure can be based on either one. We make sure we set no count to on. We select all the fields from the view or the table. Okay, that's it. There's no where clause because it's returning all the data, right? It's debatable. You might have an order by clause in here as a default order, but sometimes we leave that out and we leave it up to the client to decide and make that a separate procedure if they want to choose a different sort order at different times. Okay, so for a very generic one, we won't add an order by. Now, of course, by primary key, we have a single parameter. We pass in the ID, that integer identity value, right? So that's our input parameter, and then after setting no count to on, we simply do our select, okay? From whatever fields we want, okay, from the view or the table, and our where clause is simply based on that primary key. So that's our second standard stored procedure, right? Now, we might have as many filter by ones as we want, right? So typically, if you have a foreign key value, think of department employee again. So if we want all the employees in one department, right, we'll pass that foreign key value. In our assumptions, we said it would be an integer identity, would be basically the department ID in that scenario. That would be our foreign key value. And then we do the same select, just in our where clause, okay? We're going to have where the foreign key field matches the parameter, or we might possibly have a flag value. Why a flag value? Anybody think what we might use that for? Kind of hinted there in the comments at the top. Flag value should be a value that would never exist in actual data. Let me give you an example. If we have integer identities, what's the first value ever created when you insert data into a table and the primary key is an integer identity? The very first record will get the value 1, right? The next one will get 2, 3, and so on. Will you ever get a 0? No, right? So 0 might be useful as a flag value to allow you to use the same procedure to say, no, I want all records. Don't filter by the foreign key, right? So if you pass in 0 for that foreign key value, this code would return all records and wouldn't actually filter. So it's a way to reuse the same procedure okay, for two purposes. Give it all to me, okay, or filter by this one particular foreign key value, or basically ignore the foreign key and give me all the data. Okay? We'll see later on, we'll talk about select by X. X is my way of saying multiple who knows what, right? And we'll do the same kind of approach. So for every parameter you might want to filter by, we'll always have flag values that allow you to basically nullify that one filter and say, no, we aren't going to filter by that this time around, and so on and so forth, right? Okay, so we'll play around with more and more examples of these different sort of filter by foreign key procedures as things go on. Insert. Here's our general template for an insert standard stored procedure, right? We have all the parameters, one for everything we have to provide a value for, right? Or might want to provide a value for. They could have defaults, okay, if that is appropriate. For example, updated by. Maybe the client doesn't have that information. Maybe it doesn't require the user to log in, so it doesn't know who it is. So we're providing a default value of unknown, right? So we have to have something there because it doesn't allow null, but we don't know who it is. So we set that default value there. And again, notice we're going to add an output, right? Because with an insert, we want to return that newly generated primary key value. And this is true whether it's an integer identity or not. It might be a GUID, right, a global unique identifier generated by the system. But in any case, we want to return the value. In this case, it'll be an int because we have integer identities. So in the body of the stored procedure for any insert procedure, okay, we always set no count to off, right? And we want to have those rows affected messages return. And we do our insert command, okay? We have all of our listed fields, including our updated on and updated by. Our values, okay? And this is a common approach for the updated on. We can use the built-in getDate function. You've used that already. It's a built-in function in SQL Server. It just returns the current date time, right? So that'll provide the value of when it's actually being inserted into the database from the database's own clock, so to speak, right? The updated by value will come from the input parameter with the default of unknown. But then the next line of code, okay, so that insert does the actual work of the stored procedure, but the next line is to get that newly generated primary key, right? Scope identity, okay, is a built-in function that returns the newly generated ID value within the scope of the current transaction, right? And that will give us our value, and then we can return that to our output parameter. So the calling client that calls this stored procedure to run will have that available as an output parameter, right? Notice we have a where clause there. Where row count, okay, that's another built-in feature in SQL Server that returns how many rows were affected, right? It's a way to access that information in code. That's included here as a where clause because if the insert was rolled back because it was invalid, if you couldn't insert this record, there was some error, some parameter, who knows, there was a trigger that rolled it back, right, for example. Well, then our row count will be 0. Okay? It might not have raised an error, but it didn't insert, so our count would be 0. And so that way we would know not to try and pull our scope identity, right, because a new value was not generated, okay, for a new primary key. So we only provide a value to that output parameter if there actually is a value has been created. Any questions about the insert procedure? Again, I'm just giving you sort of templates to follow. Believe me, you're going to be making lots and lots of these standard stored procedures going forward. Okay, an update. We already talked about all these concepts. You have your parameter list for all the different data's values that you might want to update, usually one for everything in a table, right? You'll have your timestamp value and your updated by values as well, okay? So you'll update the table, you'll set all the fields to the parameter values. Updated on will use your get date, and your updated by will get the default value. But here's our timestamp. So remember how this is going to work. First, they retrieved the record, right? So they have it in the client application, and it came with the current timestamp of the last version, right, that was on the server when the user pulled the data. So that is returned, okay, as this timestamp parameter. So on the server, it can now compare, hey, does the value that the client just gave me back still match what the current value is on the server, right? that works in our where clause. So we're going to update the record where the primary key matches. So we have to make sure we're just doing the one record. And the timestamp has not changed. If it has changed, then we will not update. Delete. Delete's always the easiest thing, right? Basically, all we need is the primary key, the unique identifier for which record to delete. We don't need any other of the fields, right? And the timestamp if you have decided in consultation with your boss and everybody else on the system, right? Are we going to worry about concurrency control for deletes? If you are, then you'll need that timestamp parameter, and you use that in the where clause as well. So that's it. Those are our basic common, stored procedures. Now, the other common ones I mentioned earlier are list-style stored procedures that are there really to provide data. It's just a select data returning stored procedure, populating our combo boxes, list boxes, that kind of thing. Typically, we need them so you can select values for related data, foreign key values, and so on, right? Sometimes they're used for filtering by foreign keys as well. So it might not be that you're setting a data value on an insert or an update. It might be you're providing a drop-down list that they can use for filtering. So if you want to, on the user interface, list all your to-do items or just the ones for a given category, right? Then you'll use a drop-down list like this for that purpose, providing that filter. And I'll just quickly mention select by X. The idea here is we might have many different criteria, right? There are always ways to bypass filters we don't want to use, right? And it's the same approach that we talked about, having some sort of a flag value, or some way, what if it's a range of dates? You have a between this date and that date. We'll get into this in more detail later, but I can't help but talk about it now because it's something that is kind of fun to think about. How would you set up so that optionally, using the same stored procedure, you could specify a beginning and ending date range, right? But what if you don't want everything before the date or everything after the start date, right? Or maybe no date range at all? How might you do that? What default values could you use as a flag, sort of, to make that work? Yeah, go ahead.
Oh, Sam, sorry, I kind of zoned out for the top of the question.
Okay. Well, every data type has a defined range of values that it supports, and date time's the same, right? So if you use date time or date time 2, the oldest date is year 1 of century 1, day 1, hour 1, right? Or 0, whatever, right? So you can use that value as the default for the start date. Then if they don't provide a start date, basically it'll take everything from the earliest date possible supported by the data type to whatever value you pass for the ending date, right? And same for the last one. So if you only have a start date and you want everything, right, then you could use, you could use the current date time if you wanted, or just leave it as the maximum date, 999 year 12/31, right, as the most future date as possible. And if they don't specify any values for either the start or end date, using those defaults, the minimum and maximum values allowed by the data type itself, then you'll get all the data, right? So that's the idea of a select by X. We'll be revisiting that in the weeks to come as well. All right. So list style stored procedures to give you a bit of a template to follow, right? Again, of course, we set no count to on because it's a data returning query. We select that unique primary key, the ID, and then we might concatenate data together as some sort of a summary, right? And from the view or the table, and order it by that sum field. Oh, that should be the same name. Order it by whatever that second field is. I should fix that PowerPoint slide, right? So that's basically all you do for a lookup table, right? So you have the data for a drop-down list. The IDs are the internal values of every item in the drop-down list, and the data displayed is your concatenated field. Now, it might not have to be concatenated, right? But whatever summary field represents the information. It could just be the name of the department, for example. And that's it. So in summary, standard stored procedures, might be the only database objects accessible to the client. We'll add additional ones as required, but it's basically how most apps are built is on these stored procedures.